We're surrounded by numbers and symbols on the products we use every single day, from the stuff under our kitchen sink to the medicines in our cabinets. But what do they actually mean? Well, today we're going to decode that language. We are talking about concentration.
Okay, think about that bottle of rubbing alcohol you probably have somewhere at home. It almost certainly says 70% right there on the label. But have you ever stopped to think, 70% of what? Is that by weight, by volume? It seems like a simple question, right? But the answer opens up this whole hidden world of chemistry that we see and use all the time.
Well, it turns out that percentage is just one of several ways we express the concentration of something. You can think of these different units as a kind of language, and once you learn to speak it, you'll be able to understand what's really going on inside countless mixtures around you, from what's in your tap water to the medicine in an IV bag.
So let's start with the most common way to talk about concentration, percentages. And the first dialect, if you will, that we're going to cover is percentage by mass. This one is incredibly common, especially in consumer products.
And you know what? The idea here is actually super simple. Mass percentage, sometimes you'll see it written as percent W over W for weight over weight, is exactly what it sounds like. You're just comparing the mass of the main ingredient, what chemists call the solute, to the total mass of the whole solution. So let's take bleach, for instance. When that bottle says it's 7.4% sodium hypochlorite by mass, all it's saying is that if you were to take exactly 100 grams of that bleach, 7.4 grams of it would be the active ingredient, the NaOCl. The rest of it, mostly water. See? It's that straightforward. Okay, but what happens when you're mixing two liquids together? I mean, instead of carefully weighing them, it's often way easier to just measure out their volume. And that brings us to our second type of percentage. And yet, you probably guessed it, we're just swapping out mass for volume here. For volume percentage, or V/V, we're comparing the volume of our solute to the total volume of the solution. This is really the go-to measurement anytime you're mixing one liquid into another. And boom, that brings us right back to where we started. That 70% on the rubbing alcohol bottle, that's a volume percentage. It means that in every 100 milliliters of that solution, a full 70 milliliters are pure isopropanol. The rest is just water. See? You're already cracking the code on these labels. So let's just put these two side by side for a second. On one side, you've got mass percentage, which is perfect when you have a solid, like bleach powder, dissolved in a liquid. And on the other, you have volume percentage, the standard for any liquid in liquid solution, like the alcohol in wine or, of course, our rubbing alcohol. Two different tools for two different jobs. All right, let's shift gears a little bit. In some fields, especially in medicine and biochemistry, convenience is absolutely king. And that has led to this really popular mixed unit of concentration that kind of combines both mass and volume.
And that brings us to mass volume percentage. So instead of comparing mass to mass or volume to volume, this unit compares the mass of the solute in grams to the volume of the solution in milliliters. It's a bit of a hybrid for sure, but it's incredibly practical when you're in a lab or a hospital.
And here's a real-world example you might have even seen yourself. A standard saline drip, the kind they use in IVs in hospitals, is 0.9% MV. This is like a precise medical recipe. You dissolve exactly 0.9 grams of sodium chloride into just enough water to make a total of 100 milliliters of solution. It's a critical measurement. Where getting it right can literally be a matter of life and death. All right, so everything we've talked about so far, those are pretty big concentrations, right? But what happens when the amount of a substance is so incredibly tiny it's almost impossible to detect, yet it can still have a massive impact? Well, for that, we need to change our scale completely. Let's really try to wrap our heads around this scale. A percentage, that's just 1 part out of 100. Easy enough. Parts per million, or ppm, that's 1 part out of a million. And then you have parts per billion, or ppb, that's just 1 single part out of a billion. We need these tiny units to talk about things like trace contaminants in our environment. And this isn't just a fun fact. Here's why this matters so much. The U.S. Environmental Protection Agency, the EPA, sets the action level for lead in drinking water at just 15 parts per billion. That number sounds impossibly small, but even at that level, it's considered a potential health risk that requires immediate action. And just so we're clear, that 15 parts per billion, that's the same as saying 0.015 parts per million. It's a minuscule amount, almost impossible to even picture. So let's try to make it a bit more real. So what does that actually mean? Let's say you have a normal 300 milliliter glass of water. How much physical lead are we talking about? Well, we can figure it out. First, we'll find the mass of the water. Then, we can use that 15 ppb number to calculate the mass of the lead inside it. And finally, we'll convert that into a unit that's a little easier to understand. And here it is. That APA action level of 15 ppb works out to just 4.5 micrograms of lead in that entire glass of water. To put that in perspective, a microgram is 1/1,000,000th of a gram. That is how incredibly small a concentration can be and still be critically important for our health.
Wow. Okay, so we've gone all the way from the bleach under your sink to the water coming out of your tap. And really, what this all boils down to is that you now have the tools to understand what these labels are actually telling you. So think of it like this. You now have a toolkit for reading labels. You've got mass percent for products like bleach, volume percent for liquids mixed into other liquids like wine or rubbing alcohol, mass volume percent for those super precise medical solutions like saline, and of course, ppm and ppb for keeping an eye on environmental safety. Each tool has a very specific and a very important job.
So from now on, when you pick up a product, take a second and actually look at the label. You're not just seeing a number anymore. You're reading a precise description of what's inside. So the question is, now that you speak the language, what new details are you going to notice in the world around you?